And I know I've done this for you a few times before. But what about the integral of ln x dx? Right. This is an integration by parts problem, but it's not a product of two functions, or it's not immediately obvious as the product of two functions. And so it's tricky. But once you just know that it's integration by parts, then everything kind of falls out. You have to identify your u and dv. Now, because what I'm trying to integrate is natural log of x, I'm not going to pick natural log of x to be my dv, because whatever ends up being my dv is something I'm going to have to integrate. So that's not simplifying the problem at all. But I do know how to differentiate ln x. So I'm going to make my u ln x, because then my du is equal to the derivative of ln x, which I know is 1 over x dx. Okay. Now, what does that make my dv? Well, the only thing that's left, if the natural log of x is spoken for, is dx, or essentially just 1, right? But that means v is the antiderivative of 1, so that's x. And once you get here, you just use the formula for integration by parts. So this is u times v minus v du and this is x ln x minus the integral of just dx, so x ln x minus x plus c. So recognizing that this is an integration by parts problem is the tricky bit.
Why is it, are we only integrating dx?
Because the x's cancel. Right, so remember that the integral of the integration by parts formula is the integral of u times dv is equal to uv minus the integral of v du. So that's why I'm not integrating the x ln x. I'm only integrating the x times 1 over x dx. And then the x and the 1 over x just cancel. Does that make sense? It's one of those things, though, that if you're not familiar with it and you get to this point, you might think you've done something wrong. Like, it doesn't feel very correct. Right?
If the x is canceled, why do we still have, like, dx there?
Well, the dx doesn't cancel.
Oh, okay. Yeah. We just put, like, dx at the end every time.
Yep. I mean, because remember that du has dx by the chain rule.
Okay.
Good questions. Are we okay there?